Hey grade 12s, and welcome to this video. So in this video we're going to be working on the analytical geometry part of this paper, which is the May to June 2024 grade 12 mathematics paper 2. Okay, so we're on question 3, and question 3 says, in the diagram, A, which is 3 and 4, B and C are vertices of triangle ABC. Then they tell us that AB is produced to S, D and F are the X and Y intercepts of AC respectively. And then F is the midpoint of AC. So that is something that is important, and we can put that out. So it means that CF is equal to FA or AF, right? Because this is the midpoint. And then they tell us that, and the angle of inclination of AC is alpha. So that's the angle of inclination. The equation of AB is y is equal to kx plus 3. Okay, so that's the equation of AB, and the equation of AC is y is equal to 2x minus 2. Okay, let's move on to the first question. The first question says that we need to show that k is equal to 1 over 3. Okay, so k is, as you can see, the gradient of this line. How can we find the gradient? Well, they gave us the y-intercept, and the gradient is the only thing missing. So if you had a point and you fill in that y and the x coordinate of that point, you see that only k would be missing, and you'd be able to solve for k. So do you see now that on this line AC, we are given the point A? We can substitute that. So we have y is equal to, and they told us it's kx plus 3, and our point A is 3 and 4. So A is 3 and 4. So substitute that. The y value is 4, so 4 is equal to k, and the x value is 3 plus 3. Then we're going to say 4 and take 3 over minus 3, which of course gives us 1, is equal to k times 3 is 3k. Then we can divide both sides by 3, and therefore k is equal to 1 over 3. Okay, so that is the value of k, and we have shown them that. Moving on to the next question. The next question says, calculate the coordinates of B, the x-intercept of line AS. So we have to find B. Well, now we know that this is 1 over 3. And if this is the x-intercept, to find an x-intercept, you just have to make y equal to 0. So that's what we're going to do. So it means now that our equation is y is equal to 1 over 3x plus 3. And we'll make y equal to 0 to find the x-intercept. So 0 is equal to 1 over 3x plus 3. Now we can go ahead and take the positive 3 over. So it becomes a negative 3 is equal to 1 over 3x. And then to solve for x, divide both hand sides by 1 over 3. And so it means that x is equal to, well, negative 3 divided by 1 over 3 is negative 9. So it means that that coordinate B, the x-intercept, is negative 9 and 0. And that is our answer for that question. Okay, moving on to the next question. The next question, 3.3, says, calculate the coordinates of C. So the coordinates of C. C is this coordinate over here. How do we find that? Well, they told us that F is the midpoint, right? F is the midpoint of the line AC. I also want you to notice that F lies on the y-axis, so it's a y-intercept. In an equation, right, where we have y is equal to mx plus c, the y-intercept is the c value. So you see that we have the equation of this line, so it means that the y-intercept is negative 2. So this coordinate, as a coordinate, of course, the y-intercept, the x value is 0, and the y value is negative 2. Okay, so do you see now we can actually use the midpoint formula to find that? So here is the midpoint formula. Remember, you have it in your formula sheet as well. But we need to be careful with how we use this formula. So if this is the formula of the midpoint, remember what we're trying to say here. The midpoint of AC is F. Okay, so since we don't have C, we can go ahead and call that X and Y. Let's just establish which one is our X1 and X2 and Y1 and Y2. Because we're saying F is the midpoint of AC, it would mean that that would have to be your X1, this is your X2, or you can make that X1, it's fine. And that will be your Y1, and that's your Y2. You have to use it like that. If you use this as X2 and Y2, you will find the midpoint of this shorter line, which is in the middle here. Okay, that's not what we're trying to do. So we're going to go ahead and use this formula like that. Okay, so we're saying that midpoint, right? But the thing about it is we actually know what the midpoint is. The midpoint of AC is that coordinate F. So in place of that midpoint, we're going to say this is F, which is 0 and -2. We're going to go ahead and put that. So I can really just say is equal to, so that, you know, it's kind of like an equation. So we're saying 0 and -2 is equal to, and let's substitute, x1 is 3, so that's 3 plus x over 2. And then we have 4 plus y over 2. Okay, now here's the thing. This is the midpoint of AC. This is the calculation for the midpoint of AC. So they really represent the same thing. That means the midpoint of AC, this is the x value, and this is also the x value. This is the calculation of the x value. And this is the y value, and that is the y value. So we're going to equate the x and the y values. So that means that we're saying 0 is equal to 3 plus x over 2. And we're saying -2 is equal to 4 plus y over 2. Okay, so now that we have this, we just have to solve for x. So to solve for the x, you need to get rid of the 2 on the denominator. So we're going to multiply both sides by 2 to do that. And then 0 times 2 is still 0, which is equal to, that cancels and we have 3 plus x. Then to solve for x, take 3 over and you have that x is equal to -3. Okay, and then here, same thing, we need to get rid of the 2. So multiply both sides by 2. 2 times -2 is -4 is equal to, that cancels, 4 plus y. Then if you take your 4 over, you get -4 minus 4, which is equal to y. -4 minus 4 is -8, so y is equal to -8. And so that would mean that the coordinate of C, that endpoint we're looking for, is now -3 and -8. And that is our answer. Okay, so moving on to the next question. Okay, so the next question, 3.4, says, determine the equation of the line parallel to BC and passing through S, which is -15 and -2. Write your answer in the form of y is equal to mx plus c. Okay, so let me get the diagram down. Okay, so all they told us here is that we're finding the equation of the line parallel to BC and it passes through S. So it means that that line looks something like that because it's parallel to BC. They gave us a coordinate for S, so that is -15 and -2. Okay, when lines are parallel, it means that their gradients are exactly the same because they're slanted in the same way. So it would mean that the gradient of the line we're currently looking for is going to be the gradient of BC. So do we know the gradient of BC? Not yet. We'd have to find that. But we know the coordinates B and we know what C is as well. We found out that B, well, let's start with C. C is -3 and -8. And we knew that B, we found B already, which is -9 and 0. So let's go ahead and find the gradient first. So our gradient, the formula is this. So it means that to find the gradient of BC, we would just say y2 minus y1. We can start with the C. So -8 minus 0 over -3 minus -9, which of course when you distribute would become a +9. So the gradient of BC is equal to -8 over, this is like say 9 minus 3, which is 6. And as you can see, these, they can actually simplify. So gradient of BC is equal to, they both have a factor of 2. So that's -4 over 3. Okay, so we have the gradient now. We have the gradient of this line as well and BC. We just need to find the equation of it. They told us a point that this line passes through. It passes through S. So we can use that point to find it. Okay, so there are two equations, of course, to find the equation of a line. You can either use y is equal to mx plus c, or you can use this one, y minus y1 is equal to m times x minus x1. Now, I like to use this one, and the reason why is because I don't have to go ahead and find c first, then put it back in, which is still fine though. But this one, I don't have to. I just substitute everything, simplify, and my equation is there. So I'm going to use this equation. So I'm going to say y minus, now here's the thing, x1 and y1, those are your coordinates. Okay, so the point that it passes is s, so that's our x1 and that's our y1. So I'm saying y minus our negative 2, which is just going to be y plus 2, of course, when you distribute, is equal to negative 4 over 3 times x minus negative 15, which becomes a positive 15. Okay, so now let's distribute. Now I start here by saying it's equal to, and I start distributing, knowing that this is still here. So that is going to be negative 4 over 3x. And when you multiply, well, if you say negative 4 over 3 times 15, things can cancel diagonally. You see 15 and 3 have 3 in common. So 3 divided by 3 is 1. 15 divided by 3 is 5. So that's really negative 4 times 5, which is negative 20. It's over 1, but you know it's going to still simplify to negative 20. Then, you see with the y plus 2, I'm going to leave the y here and take this positive 2 over, and it becomes a negative 2. So it means that y is really just equal to negative 4 over 3x minus 22 when you simplify. So that is the equation of the line parallel to BC that passes through S. Okay, moving on to the next question. So the next question, 3.5, says, calculate the size of angle BAC. Okay, again, we need a diagram. So here's our diagram, and they want us to find the size of angle BAC. So really just this angle over here. Okay, so what we can use to find this angle is really the angle of inclination. So I'm going to move this shape here because I just need a little bit of space. Let's go ahead, and this is what I'm going to do. I find out how this angle was formed. And normally you have to extend certain lines to do that. So what I'm going to do is extend this line of BA. I'm going to extend that like that. So like that, and extend the line of AC like that. Okay, so now that I can see that, do you see that these two angles, they're vertically opposite? So this is BAC and that is also BAC. So let's concentrate on this one and see how that was formed. So how you find out how an angle is formed is by looking at the point of intersection between the two lines where the angle is formed. So how I'm going to do that now is I'm going to draw an imaginary x-axis. So that is really just a line that is parallel to the x-axis. So I'm going to take this line and put it here so that I can better understand how this angle was formed. So now that this line is here, what we're going to do is, let's look at this. If you look at this angle over here, remember that's the main goal. We're just trying to find this angle. Look at it as if it is a pizza slice. Imagine you had this entire piece, right? And you wanted to get that little part. So if you took away this part, then you'd be left with that. So how this angle is actually formed is by taking the angle of inclination of this line over here. And as we can see, that is the line AC. Taking the angle of inclination of AC and subtracting it by the angle of inclination of this line, which is the line AB, okay, or AS. So that's what we're going to do. We're going to find the angle of inclination. To find the angle of inclination, you just need the gradient of the line. So we're taking the angle of inclination of AC. What is the gradient of AC? The gradient of AC, here's the equation. So the gradient is 2. So since we know that, we can find its angle of inclination. The formula for angle of inclination is tan of theta is equal to the gradient. But we know our gradient is 2. So we're going to leave theta here, but I'm going to specifically call this theta of AC so I don't forget what angle it's for. So I don't forget what line it's for. And then I'm going to take tan over the equal to sign. So we get shift tan when you take it over. It's really just doing the inverse of tan. So that's going to give you shift tan of 2, right? And let's go ahead. Now I would actually want to calculate it, but let's not do that. The reason why is because when you say shift tan 2, you're going to get decimals as well, okay? So because of that, I'm not going to find the answer. I'm just going to hold on to that. So remember, I said we need to find the angle of inclination of AC and subtract it by the angle of inclination of AB. Okay, so let's find the angle of inclination of AB. Again, tan of theta is equal to the gradient of AB. The gradient of AB, we knew that, okay, is 1 over 3. So that is tan of theta equals 1 over 3. Then we leave theta here, take tan over. It becomes shift tan of 1 over 3. Okay, so now to find the angle BAC, all we're going to do is say BAC is formed by taking the angle of inclination of, remember this is AB, angle of inclination of AB, is by taking the angle of inclination of AC, the bigger angle, right, of AC, and subtracting it by the angle of inclination of AB. This one, the smaller angle, that line, okay, angle of inclination of AB. And then I'm going to take it like that so that the answer would be more accurate. So it's equal to, so that is shift tan of 2 minus shift tan of a third. Okay, so we can put this onto the calculator. So on the calculator, you just say shift tan of 2 minus shift and then tan of 1 over 3. Okay, so that gives us exactly 45 degrees, and that would be the size of a BAC. Okay, so that is our answer in that question. Okay, moving on to the last question in question 3, which says, if it is further given that the length of AC is 6 root 5 units, calculate the value of the area of triangle ABD over the area of triangle ASC. Okay, let's get the diagram down. So our diagram so long looks like this. Remember, we already found that angle there, okay? So we found out that this angle was 45 degrees. This little part here is 45 degrees. But remember, these are vertically opposite. So it is still the angle BAC. So that is 45 degrees that we have there. Okay, so I'm going to fill that in just in case it helps us. So that's 45 degrees. And let's just go ahead and see the triangles they're referring to. So they say the triangle ABD. So that's ABD. Let me highlight that. Okay, and then they spoke about the triangle ASC. So you see that we haven't really joined that one yet. So S and C gets joined and they form a triangle. So let me highlight that one. Okay, so as you can see, ASC is the green triangle and the ABD is the purple triangle. Okay, so let's see, how can we actually find the areas of these triangles? Starting with this triangle ABD. Well, in order to find the area of a triangle, there's two formulas we can use. If you have a triangle, any triangle that has a perpendicular height, so it could be like that, it could be specifically a right angle triangle where that would be your perpendicular height. It could also be an obtuse triangle where you could find a perpendicular height for it. Okay, so as long as you have the height of these triangles and you have a base as well, you can find it by saying the area of the triangle would be equal to half times the base times the height. But then there's also triangles that do not have perpendicular heights visible right there. So the area of those triangles work like this. So let's say this triangle's name was ABC. Find the area by saying a half multiplied by the side AB multiplied by the side AC. And if you have this middle angle, it's actually specifically if you have the middle angle here, and you will say sine of angle A. So we have these two formulas, right? Let's just see how we can find the areas of each of these triangles. Let's start with the purple one. So with the purple triangle, as you can see, it's actually an obtuse triangle. But here we have an advantage because we can see that the base is a horizontal line since it lies on the x-axis. And because it's a horizontal line, if we know the coordinates of D and we already have B, we can easily find its base, okay? And then, can we find its perpendicular height? Yes, we actually can. The reason why is because you see that this is the highest point of the triangle. And if you go down to the base, okay, perpendicular, we have a height. So we can actually find that because I want you to see that this point A, how we plotted or how that point was plotted was by going, okay, so it's 3 and 4. So they went 3 to the right and they went exactly 4 units up. So we know how high this is. The height of the triangle is 4 units. So we just have to find the base in this case. And to find the base, the entire base, you see that you just need the coordinates d. D is the x-intercept of this line, so we can find that. So you see that here, we can use that. We're just going to find that base. Okay, let's look at the green triangle now. So we can find the base here. So the green triangle, it's already skew. So finding a perpendicular height is not too easy here. Even this line here is not a height. It's not a perpendicular. We can't really call it that yet, okay, because we don't really know. So the only way that we could have used half base times height in the green triangle is if we maybe found out that this was perpendicular. So if lines are perpendicular, when you take their gradients and you multiply them, they give you -1. So it would mean the gradient of this and the gradient of that should give you -1. But I know it's not going to, because we know this one, the gradient is 1/3, and we found the gradient of BC to be -4/3. So it's not going to work. What we can do in the green triangle is use this area, okay? How about, so there we have a middle angle, we have 45 degrees, check. And then we would just need this side and this side. So you just need the sides adjacent that angle. So you just need the sides that are next to that angle. So we can find a S definitely because we have the coordinates, and AC, well, they actually told us something about that. They told us that AC is 6.5 units. So there we go. Now we know what we need to do. We already have that. Okay, so we can go ahead and find this. So the area of triangle ABD over the area of triangle ASC. Okay, so the area of triangle ABD, we're using a half times base times height. But hold on, we need to find the coordinate D in order to do that, okay, so for the base. So let's find D. Here is the equation of the line AC. D is the x-intercept. So to find the x-intercept, you just have to make y equal to 0. So we're saying y equals, that was 2x minus 2, and we'll just go ahead and make y equal to 0. So 0 equals 2x minus 2. Take your -2 over, which is equal to 2x. Divide both sides by 2, and x is equal to 1. So we know now what D is. It's 1 and 0. Okay, so if D is 1 and 0, what is the full length of the base? BD. This is -9. This is 1. So it means you went 1 to the right and 9 to the left. A total of 10 units. Okay, so that is a total of 10 units. You could have also said this. To find BD, you would have to say, you always have to say the bigger one minus the smaller one. So since this is 1 and 0, and this is the bigger number, you're going to say this one. So x1 minus that one, x2. Okay, so that's 1 minus -9, which is of course going to be 10. Okay, because that becomes a +9. So BD is 10 units, and we know that the height of it is 4 units. So the area of BD, we can continue with this now. So the area of ABD is a half multiplied by our base of 10 units multiplied by our height of 4 units for that triangle. Okay, we're done with that one. And now the green triangle, we already know what formula we're using there. So it's a half multiplied by this side AS. So we also have to find AS. Okay, so we're going to use the distance formula for that. Okay, so I'm just going to move that there. Let's just also move this here. I'll just put an arrow to show them that I continued there. Okay, then let's go ahead and find AS. This is the distance formula, which is in your formula sheet. So we know that A, we can just call that x1 and that's x2, and then that's y1 and y2. So AS is equal to the square root of, and we're going to take, so x2 is -15. So that's -15 minus 3 all squared plus -2 minus 4 all squared. And then you can just substitute that onto your calculator to find AS. And we get 6 square root 10. Now I'm not going to simplify that because it's not our final answer. The final question is this. So I'm not going to simplify that. Okay, so this is the area of triangle ABD over the area of triangle ASC, which we say a half, multiplied by, so remember, multiplied by the one side, which is AS, we found that to be 6 square root 10. So that's 6 root 10 multiplied by the other side of that green triangle, which is AC, and they told us that it was 6 root 5 units. So that is 6 root 5. And then multiplied by, the last thing we multiply by is sine of that angle, which is 45 degrees. So sine of 45 degrees. Okay, so you're just going to put this into the calculator and you can get your answer. Okay, remember grade 12s, use your calculator because this is not a practice, this is an exam. In an exam setting, use your calculator because it will help you save time. You need to manage your time. So this is equal to, we get 2 over 9. That is what it finally simplifies to. And that is the last question for question 3. And we finally move on to question 4. So we're on question 4, and question 4 says, in the diagram, the circle centered at C, which is 2, and P is drawn. Then we have A, which is 5 and 1, and B, -3 and -3, are points on the circle. Okay. E is the midpoint of AB. Okay, so that is the midpoint of AB. So interesting, line from the center to the midpoint. Okay. Then they say 4.1, calculate the coordinates of E, the midpoints of AB. Okay, so we have to calculate the coordinates of E. It's just the midpoint of AB, so we use the midpoint formula, which looks like this. And these are endpoints, so that can serve as x1 and x2 and y1 and y2. Okay, so we're really just saying there, we're just going to say the midpoints, we'll just call that E. Might as well just call it E. So E is really just -3 plus 5 over 2, and then -3 again plus 1 over 2. Okay, simplify. So this is like saying +5 minus 3, okay, and that is 2. So 2 over 2 gives you 1. Then that's like saying 1 minus 3, which is -2, over 2, which is -1. So there's our coordinates of E, and this is for 2 marks. Okay, so moving on to the next question. The next question, 4.2, says, calculate the length of AB. Leave your answer in third form. So the length of AB, well, let me put this down. We know that this is 1 and -1. We just need to find the length of AB. So use the distance formula, which looks like this. And we just need to use that on A and B. Might as well just use it like that. So that would be 5 minus -3, which really just becomes a 5 plus 3. So that's 5 plus 3 all squared plus, and then y2 minus y1. So that's 1 minus -3, which becomes a 1 plus 3. So that is 1 plus 3 all squared. You can substitute into your calculator. Also, grade 12s, just remember it doesn't really matter which one you name as x1 and x2. You just need to be consistent. So if you named this one first x1 and that x2, then this one has to be y1 and that y2. That's really all. Okay, so when we put that onto the calculator, this is the answer that we get. We get 4 root 5, and we don't have to put it in decimal form. So that's our answer. Okay, moving on to the next question, which is 4.3, and it says, determine the equation of the perpendicular bisector of AB in the form of y is equal to mx plus c. So the perpendicular bisector of AB. Okay, so the perpendicular bisector is just a line, so we already know that theorem. They're using Euclid here, clearly. This is the center of the circle. If this line goes from the center of the circle to this being the midpoint of this chord, right? Then the line from the center of the circle to the midpoint of the chord is always perpendicular to the chord. That is the converse theorem of theorem 1. But this is analytical geometry, so we don't really need to give them reasons. Okay, so we're going to continue. With that being said, this is the perpendicular bisector CE. We're going to use that. Now we have to find the equation of it. Well, to find the equation of the perpendicular bisector, it's a line, okay? So you just need the gradient and another point to find the y-intercept. Well, for us to do that, we first of all need the gradient of this line, but P is missing. So clearly we can use the gradient of this one, and we can use what we know about perpendicular lines and what their gradients do. So let's go ahead and find the gradient of AB first. And of course, you can use a E, it will still work out since it lies on the same line. But I'm just going to use AB because I've already labeled these ones x1 and x2 and so on. So our gradient formula looks like this. And then we're just going to substitute. Okay, so since I already labeled them like this in the diagram, I'm just going to continue like that. It's still fine. So we're going to go ahead and say 1 minus negative 3, which of course will become a plus 3 over, and we have 5 minus negative 3, which becomes a plus 3 as well. So that is really just 4 over 8 that we can see there. 4 over 8, if you simplify 4 over 8, it gives you a half. Okay, so we know the gradient of AB. Remember, that is the gradient of this chord. Now, the chord is perpendicular to this line. And what we know about perpendicular lines is that if you take the gradient of AB and you multiply it to the gradient of CE, which is the perpendicular bisector, it should give you -1. So let's substitute the gradient of AB. That's a half times the gradient of EC, and it will give us -1. So to find the gradient of EC, we just say that this is equal to, and we need to get this out of here so that we can leave this alone. It's been multiplied, so to remove it, you need to divide. So let's divide both sides by a half, and we will get gradient of EC being equal to -1 divided by a half, which is -2. And there we go. That's our gradient of EC. We're not done yet. We need to find the equation of the straight line. So now that we know this gradient, right, the equation of this line, it passes through E. So we can substitute E into the equation we have and we'll find the y-intercept. So here I'm just going to use y equals mx plus c since I used the one I like in the previous question. So remember that E is 1 and -1. Okay, so there we go. This is our x and our y value we'll substitute. So I'm just going to go ahead and substitute. We'll say y is equal to, and we'll say -2x plus c. Okay, so almost done. We just need c. Our y value is -1 is equal to -2 times 1 plus c, and -2 times 1 is -2. When you take -2 over, it becomes a +2, right? So it's +2 minus 1, which is c, and 2 minus 1 is 1. So finally, it means that y is equal to, we use this formula because it was almost complete, we just needed a c. So -2x plus 1. And that is the equation of the perpendicular bisector of AB, which is of course that line EC. Okay, so that is it for 4.3. Moving on to 4.4, which says, show that P is equal to -3. Okay, P is equal to -3. Well, we have the equation of this line now, and we know that the x value of the point C is 2. The y value is 3, so we can just do that. We're going to substitute 2 to get the y value into that equation. So y is equal to -2x plus 1, and we know c is 2 and p. So this is our x and our y. So we'll go ahead and substitute in place of y. P is equal to -2 times 2 and plus 1. So this is going to be P finally is just going to give us -2 times 2 is -4, and -4 plus 1 is -3. And there we go. So P is equal to -3. Moving on to the next question, 4.5. 4.5 says, show by calculation the equation of the circle is x squared plus y squared minus 4x plus 6y minus 12 is equal to 0. So they really just want you to find the equation of the circle. You see, in a circle, all you need to find the equation is you need the center and at least 1 point on the circumference, and then you're good to go. You can find the equation of the circle. But as you can see, the format they put it in, once we find it, we have to expand it. So let's go ahead and see. Well, right now we know what P is. P is -3. So we have that. We can use the center of the circle, and let's just use another point. I'll use A because positive numbers just seem easier to use than negative. So we can use that. We're using C and A. So this is what we have here. The equation of a circle is in your formula sheet, and it looks like this. Okay, so our center, that's what we start with. We substitute. That is your A, and that is your B value. So when we substitute, we'll just have x minus 2 all squared plus y minus -3, which of course becomes a plus 3 all squared, is equal to r squared. So you see now that this equation is almost complete, it just needs r. So to find r, we substitute this in place of x and y. So now we can go ahead and substitute that. So we're going to say our x value is 5 minus 2 squared plus y value is 1 plus 3 squared is equal to r squared. And you can substitute this into the equation to get the value of r squared. Then we can put it back into this equation. And we get that r squared is equal to 25. So 25 equals r squared. So let's put that back into this part. So we'll say, therefore, just put it in and put r squared there. So equals 25. And remember, they want it in this format, so we need to expand it. So let's expand. You see where you have x minus 2 all squared, you can choose to go x minus 2 times x minus 2, which takes long. In math, you need to try and take shorter steps because it will help you avoid mistakes. You're human, so you can make little mistakes here and there. But the shorter the steps, the lower the chance of you making little mistakes. So what I'm going to do instead is use the quick method. You take the first term and you square it. That gives you x squared. Then you say the first term multiplied by the second term, which we can see would give us negative 2x. Then you multiply that by 2. So that gives you negative 4x. Then lastly, you square the last term, which is positive 4. Okay, so you do the same thing here. Square the first term, that's positive y squared. First term times second term, that's 3y times 2 is positive 6y. Square the last term, positive 9 is equal to 25. Okay, let's put it in the same order that they wanted. They first put the x squared, then we have the positive y squared, then they put the thing with the x, so minus 4x, which doesn't have any like term, as you can see. Then the positive 6y. Then we can say this positive 4. Well, I might as well just take that 25 over. So bring the 25 over, becomes negative 25 is equal to 0. So positive 4 plus 9, and that gives you 13. Then minus 25, 13 minus 25 is negative 12, okay? Because 25 minus 13 is 12. So negative 12 is equal to 0. So that is it for 4.5, and then we move on to the last question in question 4. Okay, so we're on the last question in question 4, 4.6, which says, calculate the values of t for which the straight line y is equal to tx plus 8 will not intersect the circle. Okay. Honestly, it seems like a visual question, so I'm going to bring the diagram down and just look at it quickly. So, for which it will not intersect, you see, if you have your circle and you have that equation, now we don't know what the gradient is. It could be an increasing function or a decreasing function, we don't know. But we just know that the y-intercept is 8. So that line cuts 8. And it goes like that, basically. It could be like that. It could also be the other way. So for you to find out for which values of t it will not intersect the circle, the only points, not the only, but the first point where it will intersect the circle, it will have to be a tangent to the circle. So it's like, goes like that, and then it touches the circle at one point, right? And then after that, it can kind of like move. Well, the way I drew it now, it's not going to move properly. I should draw it from here. So it's kind of like this. If this is your line, a visual example of this is looking at it like this. This line eventually is going to touch the circle. And then if it keeps moving like this, it will keep touching the circle and keep touching the circle. And then it touches the circle one more time. Then after that, it stops intersecting the circle because it's far away, because it's away from the circle enough for it not to touch. But the thing is, to actually find this, we can continue looking at it. There's not enough data to find it like that, like if you try to find it visually. Okay, so especially because this is a circle and not a parabola, I feel like even if it was a parabola, it wouldn't also just be easy to, well, it would be better because a parabola, you can at least find the gradient of a parabola. So in this situation, I don't think we should be looking at it visually because it's not really working. But I only like to show this just so that you can understand what the gradient does, what that t value is doing. It only changes the slope, but it will forever cut 8. That's really what they're saying. Well, the line needs to cut 8. Okay, so I can't really find this because there is not enough data, or maybe I'm not really thinking it through properly. So I'm not going to find it like that. Let's look at a more equation way of looking at this. Fine. They said calculate the values of t, right? For which the straight line y is equal to tx plus 8 will not intersect the circle. Okay, how about we find out the values of t for which it, or let's make the line intersect the circle first, then find out the values of t for which it will not intersect the circle. So there's a reason they gave us this equation. It's actually easier to use in this case. So our line is y is equal to tx plus 8. And our circle is that x squared plus y squared minus 4x plus 6y minus 12 equals 0. Right? That's our circle. Let's go ahead and make them intersect first. Then we'll find out for which values of t they will not intersect. Well, for these two to intersect, it's kind of like making, well, this one starts with y is equal to, and this one has x and y. It's like making y equal to y, but you can't really make y the subject here. So what I'm going to do is treat this as a simultaneous equation, okay? So if you treat it as a simultaneous equation, in simultaneous equations, what you're trying to find out is the points of intersection of the two graphs that they give you. That's what I'm going to do. Let's go ahead and take this, since it's a straight line equation, it's a linear equation, we can substitute it into this. So it's like taking equation 1 and substituting it into equation 2. Okay, so every time you see y in this equation, replace it with tx plus 8. So you have to be very careful here not to make little mistakes, because that's where they can catch us. So we're going to say this is x squared plus y. Okay, I see y, so change. It's going to be tx plus 8. Now that's y squared, so this needs to be squared. Okay, and then we have minus 4x, then plus 6y. So that is again tx plus 8. I'm just trying to be careful because I can make silly mistakes. So we have x squared, and then let's work on this now. So I'm going to use that same way that I used to square this, because it's so much helpful here so we don't make mistakes. Square the first term. You see they're both variables. So t will become t squared, and then x becomes x squared. That's squaring the first term. Then you say first term multiplied by second term. You see that will give you 8tx. Then you need to multiply that by 2. So we get positive 16tx. Then square the last term, which is positive 64. Okay, then we have minus 4x. Then let's distribute. That's going to be positive 6tx. And that's going to give us positive 48 and then minus 12. Now here, I don't want to make mistakes. Let's just go ahead and start adding like terms. Okay, that's all we have to do here anyways. So x squared. Funny enough, these two are actually like terms. If this was not a t squared, I might as well just leave them together. Let's just say x squared plus t squared x squared. Okay. Does anything else have a tx? Well, we have 6tx. Okay, so 16 plus 6 is, that's for 22. So we have positive 22tx. That's done. Okay, of course, we're also done with those ones. Then we have okay, let's hold on to the constant. We'll add these constants afterwards. So the last variable we have is minus, last thing with the variable, minus 4x. Okay, now our numbers. 64 plus 48, well, 60 plus 40 is 100, 4 plus 8 is 12. So that's 112, but then we have a minus 12, so which is positive 100 we have, is equal to 0. Okay, you can also just double check with the calculator as well, which I did. And so now we have, when I'm looking at this equation, it looks like it has like terms, but the t is really just disrupting it. So because the highest exponent on x is 2, it is a quadratic equation, which is very good, because remember, we're just trying to find out the values of t for which these will not intersect. Okay, so since it's a quadratic equation, we can go ahead and use the discriminant, which I call delta because the symbol delta is called delta. Okay, so the symbol for discriminant is called delta. So we have this, and we can go ahead and, well, it is a quadratic equation, but it's not in its standard form yet. Remember that the quadratic equation standard form looks like this. It's ax squared plus bx plus c, meaning you need to have something which has a variable of x squared, which has a variable of x, and then a constant. I see that here. We just have to group certain things. So what I'm going to do is, this has x squared, this has x squared. Let's group that together. We'll take x squared out as the common factor so that we can see the coefficient of x squared. This one has x. Yeah, it has a t, but it has x and that has x. So we'll also group those two together so that we can also see that. And then that will just be our constant. So take x squared out as a common factor. And what is left? You'll be left with 1. And then here you're left with positive t squared. Okay, here, I know the highest common factor is not just x, but I'm specifically trying to get x out so I can see the coefficient of x. So I'm only going to take x out as a common factor. And what is left? So with 22tx, the x is already there, so we just have 22t, right? If you take 22t, multiply by x, you get back to that. Then here, what is left? Just a negative 4. And then plus 100 is equal to 0, which is perfect now. So now I can see that the coefficient of x squared, the a, is this number. That is our a. And then the coefficient of x, which is the b, is this number, because that's what's being multiplied to x. And then the constant is just 100. So this is b, this is 100. Constant is 100. Okay, so now we just need to find out the values of t for which it will not intersect the circle. Right now, it is intersecting the circle, but we need to make it not intersect the circle. To make it not intersect the circle, because you have a quadratic equation, we're going to tamper with the discriminant. If we make the discriminant equal to 0, you will have real roots here, meaning it will really intersect. Okay? So we don't want it to intersect. We don't want real roots. If you make it greater than 0, it will also have real roots and it will also intersect. But if we make the discriminant less than 0, then it's not going to intersect. And that's what we're trying to go for. So we're going to make the discriminant less than 0. So delta is b squared minus 4ac. I'm going to make that less than 0. Our b value we now know is 22t minus 4. So we say, I'm going to put it in blue, 22t minus 4, and we're going to square that because b is squared, minus 4, and then a. Well, a is 1 plus t squared, so 1 plus t squared. And then we have c. Well, c is 100, so you just put that in. 100 is less than 0. Okay, a lot of squares, and we just have to be really careful here. Let's go ahead. So the first thing we're doing is we're squaring 22t. Well, 22, square 22. 22 squared is 484. Okay, you could manually calculate it, but that takes long. You need a calculator here. Then that's 484 t squared, right? We square that. Then you say 22t multiplied by negative 4, which is negative 88t. And then you need to multiply that by 2. So 88 times 2 is 176. So that is negative 176t. I'm just trying to be really careful here. Negative 4, square that. That is positive 16. Okay, done with that part. Let's keep moving. Okay, let's just be careful on how we're going to multiply this. I see that this can distribute in like that. But remember, it's being multiplied all through. Let's multiply the negative 4 and the 100 first, which will give us negative 400. Then say that is being multiplied by 1 plus t squared. Okay, it's less than 0. Okay, so now we just have to distribute here. So we still have the 484 t squared. And then we have this. So that doesn't really have a like term with anything. So minus 76t then plus 16. And then when we distribute here, we get negative 400, and then that gives us a negative 400 t squared, and that is less than 0. Okay, so now we just have to put our like terms together. So do you see that we have t squared and t squared? So that is 484 minus 400, which will give you 84 t squared. Then we have, this is the only thing with t again, so negative 176t. And then we have a positive 16 minus 400. So what does that give us? And we get negative 384. And all of that is less than 0. Okay. Now at this point, this is a quadratic equation, as you can see. It's a quadratic inequality. Now we just really need to solve for the quadratic inequality. So I know there's definitely a common factor, and how I'll find out whether there's a common factor or not is I'm just going to take each of these numbers and see what they have in common. So if you take 84 is equal to, just see the factors it has, shift and factorize. I see it has 2 squared. You would probably have to do that and then write down the factors that you're seeing in common. Then I'll just say 176 is equal to, and shift and factorize. And then lastly, 384 is equal to shift and factorize. Okay, so do you see that all of these factors, they all have 2 in them? So between 2 squared, 2 to the power of 4, and 2 to the power of 7, what is the common factor that you have? That would be 2 squared. So it means 4 is common between all of them. So what we can do here in this inequality is divide both hand sides by 4. And then let's see what we get. So 84 divided by 4 gives you 21. So 21 t squared. Then 176 divided by 4, that gives you negative 44 t. And then the 384 divided by 4, that gives us negative 96. Is less than 0 divided by 4 is still 0. Okay, so now we're at this point. We don't know if it factorizes or not. So what we can do is, instead of looking for factors, I will open up 2 brackets like I'm going to actually factorize. But I'm going to use the quadratic formula because we need to save time and rather just use quicker methods but still get marks for factorizing if they are given marks for factorizing. So how we'll do that is we'll use the quadratic formula. We just will not show them that we have used the quadratic formula. Okay, so this is the quadratic formula. So I'm going to put a fraction and I'm saying negative. Now we're going to say negative b. So bracket negative 44 plus minus, okay, I'm starting with plus, the square root of b squared, which is negative 44 squared, minus 4 times a, which is 21, and then times c, which is negative 96. And that goes all over 2a, which is 21. Okay, so we get fractions. Now here's how to work with stuff like this. I know in the past I've shown you guys how to use the quadratic formula on quadratic equations, but the ones that have x squared. So the ones with the coefficient, this is how it's going to work. Remember that that's giving you your critical value, meaning your solution for t, right? It's telling you that t is equal to 24 over 7. So how you're going to put it as a factor here is, you see the denominator. The reason you divided by 7 is because the 7 was in front of the t. So what you had before was the 7t, and then you see this 24. It's like taking it over the equal to sign and becomes a negative 24. Then you see now that if you said 7t minus 24 is equal to 0, then you'd have said 7t is equal to 24, and then you'd have divided both sides by 7, you see, to get that. So that's what we did there. And then to get this factor, the other one, we would just change that to a minus. And we get negative 4 over 3. Same thing. T is equal to negative 4 over 3. The denominator is your coefficient of t. And then you take that number as if it's coming over the equal to sign and becomes a positive 4. So there, it looks like we factorized. Okay, so we have our critical values and our factors as well. Okay, so these are the critical values we have. Now remember, this is a quadratic inequality and we're trying to solve for it. So also notice, because it's quadratic, it will form a parabola. But specifically, what type of parabola? Well, the value of a is greater than 0, so it would be concave up parabola. So your parabola would be like this. You have your concave parabola. Here's your x-axis. And so the smaller value is the -1, of course. So that's -4/3. That's your first root. Your second root is the 24/7. So your inequality is asking for the values of t for which the y value is less than 0. When we ask for values that are greater than 0, so if you ever see greater than 0, you would take parts of the graph that are above the x-axis. And if they say less than 0, this would be parts of the graph below the x-axis. So clearly, because our inequality says that our expression needs to be less than 0, we're only going to focus on the parts of the graph that lie below the x-axis. And so what are the values of x, or t rather, for this? So if I line this up to the x-axis, you see the values I get. These are values that are greater than -4/3, but less than 24/7. Okay, because that's the direction they're moving towards. That's these values that we see here. Okay, so we're going to therefore say that our solution to this is t needs to be greater than -4/3, but less than 24/7. And that would be our answer to this question. So it's a long one. Let's see why it's 6 marks. So that's the answer. And I can bring back the visual example back so that you can see what is actually happening. Okay, so this is what this means. Remember that this is the value of t, right? In that equation, y equals tx plus 8. Because this is in the form of y equals mx plus c, and you know c is your y-intercept, we know that the graph, the line, right, has to cut the y-axis at 8. Now, the t represents the gradient, and you know that if the gradient looks like this, it's an increasing function, so your gradient is positive. If it looks like that, it's a decreasing function, so your gradient is negative. So it means the gradient could have been various things. So now we know what the gradient should be for it to not intersect the circle. So this is an example of that. What's going on is that you have that line, right, passing that y-axis. And I'm going to just have to put it like this so that I can move it around. So when the gradient changes, it's going to change the slant or the slope of this graph. It's going to make it move around. So let's look at it like this. When the value of t was exactly -4/3, because this is a negative gradient, it would probably have been this one, right? So it was probably touching the graph at one point here. Then when it became greater than -4/3, it starts to increase. What happened is that your graph started to increase in gradient, okay? When it started to increase, it maybe just did this, right? And then it had to just be lower than 24/7, which is a positive gradient. But then if it went anything beyond that, what would have happened is that your graph would have started intersecting the circle. It would have first intersect the circle at one place here. Then if you keep moving, it will intersect here and there. Keep moving, intersects, you know, here and there. And that's really what's going on. Okay, let me also just show you on Desmos what's actually going on so that it's not like I'm just making this up. Okay, so here on Desmos, here is the equation of the circle. And here I just put x plus 8. So we will put coefficient or gradients for that graph. You see what happened is when I substitute -4/3. So if you substitute -4/3 there, do you see what happens? It's a negative gradient and it intersects the graph at one point. We were specifically looking for values of t where this graph will never intersect the circle. So that's why it can't be equal to -4/3 first of all. So when we put it like that, that's what happens. How about, because we said that t needs to be greater than -4/3, right? So it should get bigger from -4/3. Let's substitute a value bigger than -4/3. -4/3 is -1.33. If you move on a number line, you can try -1, which as a fraction is -3/3. So look at what happens when we do that. You see how that graph moves away from the circle? It stops intersecting the circle. And if you try something bigger, like -2/3, it goes even further away. And you could do this and you'll see that it just keeps moving and moving, like the way I was trying to spin it around to show you what was going on. We can even try it from this side. When it is 24/7, let me substitute that there, and then let's see what it does. So you see what the graph does at 24/7. And then of course, if you start to, because in this case, t needs to be less than 24/7. So if you start to decrease that, so anything lower on the numerator would decrease this because this is an improper fraction. So let's say we try 20, right? Let's try that 20/7. You see how it moves away. Okay, so values that are less than 24/7 are working there. If I change that to maybe even something like 15, see, moves further away. So it was a very interesting question. So that is a visual example of what's actually going on and what the gradient really does to a line. Okay, so that is it for this part of this paper. Then I will see you guys in trigonometry and Euclidean geometry of this paper. And I apologize for not uploading it so quickly. I have been really busy at work, so I'm really just trying to balance it all out. And I will try my best to upload everything before the end of the week. Fingers crossed though. So I'll see you guys in the later videos.